Welcome. The topic of today's discussion is logical connectives. If to be exact, we are going to discuss what is conditional. And we have distinguished several questions in order to clarify the topic. Question 1. What is a conditional as a logical connective? Question 2. Other names for conditionals. Material implication. And question 3 is about logical consequence, and our last question for today's discussion is about antecedent and consequent. Okay, let's start with the first question. What is conditional? How can we explain this logical connective? We can express relations between propositions by waves of conditionals. For example, if it rains, then I'll get wet. In this example, we have got two simple statements. Simple statement 1, that's P statement, it rains, and our second simple statement Q, I'll get wet. As a result, I can combine these two simple statements, and I can express my idea by this way. If it rains, then I'll get wet. In order to combine these simple statements, I've used logical connective if then, and you can see its symbol in the presentation. Okay, and our next slide is about other names for conditionals. The first name can be expressed by this way: material implication. And how can we explain material implication? First meaning is that this is the formal name used in classical propositional logic, and second meaning is about the emphasize that the truth of the conditional depends only on the truth values of P and Q. And the second name for conditionals is implication. It's a common shorthand, especially in mathematics and logic. And another name, if-then statement. It is the most intuitive, everyday way of expressing a conditional. If P, then Q. And the logical consequence, sometimes used when Q logically follows from P, though technically this refers to a stronger semantic relationship. Okay, let's clarify material implication. How can we explain this name for conditional? Conditionals are also known as material implication in logic, as we have said before. That means that the statement if P then Q is considered true or false, based purely on the truth of P and Q, not whether there is a real world link between them. In other words, material implication emphasizes that the truth value of the conditional statement depends solely on the truth values of its components rather than any causal or temporal connection between them. Okay, and even if there is no cause and effect relationship between P and Q, can we construct a conditional statement if P then Q in logic? We can answer to this question in a positive way, that is absolutely yes. In logic, you can construct a conditional statement if P then Q, even if there is no causal relation between P and Q, because in formal logic, the conditional if P then Q is defined purely in terms of truth values, not real-world causality. The material condition if P then Q is a rule that says the whole statement is false only when P is true and Q is false. In all other cases, it is true. Okay, our next discussion is about example of material implication, not causal link here. Our P statement, the moon is made of cheese. Our Q statement, 2 plus 2 is 4. Now consider if the moon is made of cheese, then 2 plus 2 is 4. This is logically true statement because P is false and Q is true. Even though these two ideas have nothing to do with each other, the conditional is valid in formal logic. And what's about logical consequence? Logical consequence is a fundamental concept in logic. It means that a statement, the conclusion must be true if certain other statements, the premises are true. In symbolic way, we can express these logical consequence in the following way. If P1, P2 up to the Pn entails Q, then Q is a logical consequence of P1 through Pn. And you can see the symbol of entailment in the slide. This symbol is read as entails or logically implies. And our example for logical consequence. P1. If knowledge requires justification, then beliefs based on hearsay are not knowledge. If P, then Q. Our second premise, if beliefs based on hearsay are not knowledge, then most superstitious beliefs are not knowledge. If Q, then R. Our next premise, P3. If most superstitious beliefs are not knowledge, then we should revise traditional epistemologies. If R, then S. Our last premise, knowledge requires justification, P, and our conclusion, we should revise traditional epistemologies, S. Since S is true in every case where all the premises are true, this is a valid example of a logical consequence. Okay, key idea. In logical consequence, a conclusion logically follows from premises if it is impossible for all the premises to be true and the conclusion to be false. This is about form and truth preservation, not about meaning of real-world causality. And how can we compare material implication with the logical consequence? Material implication, if P then Q, a truth functional connective used in propositional logic. Second attribute is about its truth values, that is, material implication depends on truth values of P and Q, and the last attribute can be stated in the following way. Material implication allows unrelated P and Q. As we have seen it in our previous example, if moon is made of cheese, 2 plus 2 is 4. And what's about logical consequence? P entails Q. First item is that semantic, that is metalogical relation can be stated in this logical consequence. Second attribute is about the logical necessity, that is logical consequence depends on logical necessity. And the last item is about the unrelated P and Q. Unlike material implication, logical consequence does not allow unrelated P and Q. And antecedent and consequent. The one connection expressed in a conditional can be expressed in many different forms of words. For example, we can say if P then Q, we can say if P Q, we can say Q if P, of P only if Q, of P implies Q. In each of these cases, we say that P is the antecedent and Q is the consequent. And in each case, the statement tells us that if P is true, so is Q. In each case, the statement is refuted if P is true and Q is not. Note that in Q, if P, the consequent comes first. The only in P only if Q flips the order in the if back to the antecedent first and consequent second. Okay, our conclusion about today's discussion, that's applying what we learned. 1. For propositions P and Q, the conditional if P then Q is a proposition which we will write as P symbol of conditional operator and Q. P is the antecedent and Q is a consequent of the conditional, and you can see its symbolic expression in the slide. Second, it's important to understand that in a conditional, we are not making a claim about whether the antecedent causes the consequent. 3. When I say if it rains, then I'll get wet, then the antecedent is it rains, the first simple statement, and the consequent is I'll get wet, the second simple statement, and here typically the rain causes me to get wet. And 4. However, I could equally say I'll get wet only if it rains. In this case, the I'll get wet is the antecedent, while it rains is the consequent. In this case, my getting wet doesn't cause the rain. The rain, if it rains, causes me to get wet, not the opposite version. But if we know that the conditional is true, we can learn that it has rained when we learn that I've got wet. And the last item is about the connection expressed in the conditional. That is, the connection expressed in the conditional is a connection in the truth or falsity of the antecedent and the consequent. It is not claiming that the antecedent causes the consequent. Okay, that's all for today's discussion. If you have got any questions, you can address them and I'll be very glad to answer them. Thank you for watching.